Hey, hi, morning. Okay, I'm just going to go through the agenda just very quickly. I'll talk about this. Just to let you know, if you wanted the slides, these are the URLs. There's a PDF version. This is the HTML version you're looking at. I'll go through the intro, what's the current practice in our institute, what's the problem with our current practice, as well as our proposed solution, what I'm proposing, and what the benefits of this solution are, as well as some discussion about it. Okay, I'll skip this slide because this is just about myself. Okay, you're here in this institute, Republic Polytechnic. What we do here is that we use a method called problem-based learning. Okay, the issue with problem-based learning is that we create a lot of artifacts, a lot of documents have to be created almost every week just to support this learning. For example, there is what we call a problem statement, which is usually done in a Word document. Some worksheet, which is a scaffolding process to allow the students to learn better. Then after that, we have to give them the solution. Then there's some quizzes and the exams, etc. So most of this would also contain some code listings, UML diagrams, or images. Okay, so our current practice is that our module team, which is the left-hand side, the module chair and the problem crafter, have to create the content, which is those documents that you saw just now. We have an independent reviewer who will come and review the content. So this person will check to see whether we're meeting our learning objectives, whether or not our content has any grammatical errors, etc., etc. So after a few rounds of revisions, then my module chair would upload the content so that our students can access it. And he has to package the content because our learning management system doesn't accept single file uploads. It's a lot easier if they are all packaged together. Okay, just another view from a workflow perspective. What happens is that creation will happen first, and this part here, edit and review, is a cycle which will continue until the review process is cleared before the content is packaged and released. Okay, it's not so easy to just create the content. For example, most of the modules I teach are very programming based. So in this case, we have to show them code samples. In this case, you'll see that it's very hard to read black and white code samples. So we have to try to colorize it so that at least for people who are visual learners, they are able to more easily see this. Going forward, because some of our modules we are trying to teach intro programming. In that case, we don't want them to just be able to copy and paste the whole entire answer. So what we had to do was that we had to transform our answers into an image. What we usually do is that we open an editor, like for example this one, and then we would have this as an image, and then we will, let's say, use a snapshot tool and capture the image. Okay, so that our students would be able to see the image, but they have to physically type it in themselves. And of course, sometimes we put images just for fun. Right? What happens is that for most of this, we use different Microsoft tools to create this at present, for most of our modules. The primary reason is, of course, this is our Microsoft campus, and we have a campus-wide license for Office. So we use Word for documents, PowerPoint for presentations. Our quizzes and exams are done in Word first, so that we can print them out on paper, as well as to upload to an online client. You saw that the code listing was to use any screenshot tool, so you can use the built-in one in Windows or one on the Mac. For UML diagrams, I think most people use Visual, and sometimes if we need to resize images, we will use some photo editor tools. Okay, the problem with this is like that snapshot image that you saw, right? If I made a typo in that image, what do I have to do? First, I have to check, do I still have the original file, the same file that I created the image from? Because this could have been like maybe a few weeks after. We usually do the preparations in the holidays. So by the time we discover the mistake, it could be like maybe a month later when we're doing the review process. Then I have to find the original file. If I can find the file, that's good, then I just change the typo. But if I can't find the file, then I have to recreate the whole image again, which means I have to go and type out the same lines of codes again, snapshot it as the image. Okay, then I have to replace the old image with the new image. sorry, excuse me, replace the old images with the new images. This has to be done for every document. So for example, if I gave you a PDF version which had that guessing game slide, I had to replace it. If it was in my answer, I had to also replace it as well. And if it's in another document, I have to replace those as well. Then again, I have to package all the documents together and then I upload it so that our students are able to access this. So this is very tedious. Another thing that happens is that there is no version control. Because we use Microsoft tools, it's a bit harder to track it as a binary file. We can't just use a Subversion or CVS to track this. So one way we could have done is that we could use the track changes here. But the problem is most of my colleagues tend to forget to toggle this button when they're using it, which is one issue. Another issue is that it's too granular in the sense that if I'm making a system-wide change, let's say we changed our objective. Our objective was that we needed to do something else differently, and this impacted a few documents, not just one. There is no way to tie in this change to that process. And another problem we have is that it's now very difficult to shift towards mobile learning, because if you want to do mobile learning, what we have to do is that we produce mobile content in forms of EPUB or HTML or PDFs, which means we have to keep different pieces of content synchronized. So this document that you see, which is in HTML, the other document that you see, which is here, which is this one, is a PDF. If I made a change somewhere, I have to make sure that I make the same changes here so that the content doesn't go out of sync. This is hard enough to do with just two. If you wanted to add more different types of outputs, you'll get more harder and harder as it goes along. Okay, so I came out with a solution. What I did was I found a few open source tools. The rows of the tools on the left hand side. That means I found some tools, 6 of them in this case, which will help in this process. One of them is a document converter, which is called PenDoc, a build automator, which is called SCons, a syntax highlighter, which is Pigments, UML sketcher tool, which is Plant UML, image manipulator, which is Pill, and a version control, which is Mercurial. Okay, so how do this all work? What happens is that Scons is my build automation tool. It uses the other tools like Plant, UML, Pigments, and Pill to create different contents. So as you can see, in this case, Plant will produce the UML content, Pigments will produce the code listings, and Pill is for images. Then we use PenDoc to tie everything together, which takes all the content and together with a source document in a markdown format and produce the various different types of outputs that you see. So this is the format that I used to demonstrate to do for this bunch of slides as well. Okay, what is PenDoc? PenDoc is a converter that reads certain types of formats as an input and produces multiple formats. So it can do this many types of formats, which was one of the reasons why I chose it up front. There were a few alternatives that we could have used. One of them was I could write DocBook, but as you can see, DocBook is XML based, which means to alter a content here by hand it will be very tedious. You have to balance the text and everything, and if you made a typo, everything would go wrong, just like how XML is. So that's one issue. Alternatively, I could learn LaTeX, but to be honest, I haven't learned LaTeX before, so and I don't think my colleagues will be very willing to learn what all those slash means and everything. So it will be a bit harder in this sense. So that's why I stuck with PenDoc. Okay, what Scons does is that it's a build automation tool. It handles dependencies. What happens here is that, let's say I made a change to one of my code listings or my UML images, they would automatically recreate the source documents again from the PenDoc for those that are affected. I'll probably show you a small demo later after this. Okay, there are a few alternatives, but most of these alternatives depends a lot on the languages that you are supposed to be using. For example, if you're using if you're producing C or C++ files, you use Make. If you're doing Java files, you do Maven or Ant or rig for Ruby. But the problem is I'm not very familiar with these languages, and as my content, if you notice my content here is not actually a program, it's actually a document file. It doesn't make much sense to use anything that in this case so it wouldn't have made a difference. So I chose Python because I use it to teach intro programming as well as some other modules. So I'm slightly more well versed in Python than say C or C++ or Ruby for that matter. And it's slightly better at integrating some components together as opposed to things like Java. Pigments, the use of pigments is that it produces this file, which is this image file in that is syntax highlighted. The nice thing about it is that it's Python-based, which means that scones can directly control it as opposed to just allowing it to be used as a command line, which is the other alternative. There are a few alternatives here again. One of them is, but the problem is that they only usually produce colored text. The main purpose of these other alternatives is that you have a web page with code listings and you want to highlight it for your viewers to see. So they are usually JavaScript based, or they produce HTML codes only. They don't produce an image, which was the issue that I wanted, because if you remember from the start, the point of having images is such that so that we don't want our students to copy it so that they have to manually type it out. Okay, after getting the images, whether is it through pigments or some other funny images that you found on the web, or even the picture of LP that you saw up front, sometimes we have to resize the images because the images are too big to fit onto the screen. So in fact, the original image I had of LP was quite big. It would have been unable to fit inside the screen itself. So this was the original image. I had to shrink it down a little bit. It's a bit hard to see, but it's shrunk down a little bit so that it's able to fit on the same screen. So I'll need a tool for this which you can drive through your command line. In this case, we use Peel, which is the Python image library. There are nice alternatives like ImageMagick and Carol, which are very well used, but the problem is that Peel was slightly better because it just came with Python. So that means instead of scripting it as a command line, it is you can just install it and it will just work with Python. As opposed to something like ImageMagick, where you have to install ImageMagick separately and then install a client with Python so that the both of them can combine to talk. Okay. Carol doesn't work because it's vector-based, so most of my images like this will be raster images. I use Mercurial because it's a distributed version control. The idea is that we can commit without having a central server, and is able to easily branch, which means other of my colleagues, because we usually do this as a team, so I might create a few contents and then somebody else might create some more and then we assemble it together. So sometimes we might have arguments or some different opinions about things. So what we could do is that we could create a new branch, try out how the content will look like if we took a different path, and then we can see from there. Okay. There are a few alternatives to Mercurial. Of course, you could use JIT. I didn't because I used Bitbucket at the first, and Bitbucket only used to support Mercurial. But JIT works just as well if you're fine with JIT and GitHub. Otherwise, you could use Subversion, but the problem is, of course, it's a centralized server, which means it's you have to be connected every time you make a commit, which is slightly difficult sometimes, especially if at home, since I don't have a very fast internet connection. Okay, so what's the benefits? The benefits is that okay, the source itself is in plain text, so it allows it allows us to use tools like Vim or Emacs, which makes it easy to work with plain text. So if you can see down here, this document that you're looking at is actually created from this markdown source. Right, so this was the same document you saw just now, you're looking at in the presentation, just marked down in text format. So because you can use Vim, you can do nice things like you have folds, you can do a lot of other things like do search and replaces, a lot more easier than if you are using something like Microsoft Office. Yep. Okay. So I just happen to be a Vim user. I'm sure if you are Emacs user, it will work just as fine. Okay. Another advantage of open source is that it's usually free. So most of this, which is good because as an education institute, I don't get a budget for creating materials, so there's no money to go about for buying licenses, which is one issue. Another issue is that for open source is that it has frequent updates. Just to show you this small footnote, let me see if I can open it. Sorry, should have opened this. Yeah. Oh, done. Did I? Okay. Yeah, so this is actually PenDoc. As you can see, the author for PenDoc is quite prolific. He actually releases a new point version almost every other month or so. So that's one good thing. The nice thing was that this issue that I raised to the author. So I went to GitHub and I actually told the author that actually for certain cases, let me see if I can find his code here. So at GitHub, I raised the issue to tell him that there was a small bug with inline text. So if I wanted to do inline text and I wanted to color it so that you will get those nice syntax highlighting, it doesn't allow you to see. So I only did this 9 days ago. Yeah, so he fixed it in the last 6 days. So when I wrote this, if I wanted the print word to light up in syntax highlighting, so I submitted this issue to him. I told him that if I wrote this and I showed him this Python to tag it as Python so that the print would be syntax highlighted, it doesn't actually produce the right thing. It will give me an error. So he found the bug and he fixed it 9 days ago. Yeah, which was quite nice. So that's why now in this example I have this syntax highlighting. So that's one nice use of one advantage for open source. So another advantage is that even if the author himself didn't want to fix it, I could have gone into the source myself and tried to figure out what was wrong. I didn't because PenDoc is written in Haskell and I'm not a Haskell expert. So I just wrote an issue in this case. Okay, the nice thing about this approach is that it's very modular. So if something doesn't work or if we change different modules, what we can do is we can swap out the module and replace it with another one. So if one of my colleagues who is teaching an Android module wants to use this method, what he can do is that instead of highlighting Python, all he has to do is cause pigment to shift to Java instead. Or alternatively, if they are teaching a database, you can, instead of using plant UML, you can use another library which you can generate ELD. So most of this is like the top one is actually quite straightforward. Just to show you again, this is the build file. So the part that highlights is just this portion here. So this only highlights as Python because I said it was a Python lexer. So if you wanted it as Java, all you had to do was import a Java lexer and change this portion here, and you would highlight it as though it was Java. Another good thing about PenDoc is that it's scriptable in the sense that even if you don't know Haskell, in that it reads and writes JSON. So what it does is that it takes this file, this original file, which is this one, and it transforms it into JSON that looks like this. So this is equivalent to something like the header here, this line here. So this is a third level header. That was a first level header. All right. So this is a first level header with this text inside. So because it's JSON, and PenDoc reads and writes this value. So what you can do is that even if you don't understand Haskell, we can ask PenDoc to produce JSON. We read it in through another script, manipulate the script, and then produce out JSON, and then feed it back into PenDoc again. So this was the approach I did for the exams. So in my exams, I have a script where there's pre-existing answers, because we need to know the answers when we are doing the review. But of course, we also need another version without the answers, just so that our students can print it out. So they can print it out for our students to do on actual paper. But these two versions have to be in sync. If something is not in sync, then that's very bad, because this is an exam. It's very high stakes. Our students know that this would take like 50% of their grades or something if something goes wrong. So to make sure that happens, we again make sure that what I did was I wrote a version which had the answers, and then I push out the version, choose JSON, I strip out the answers, and I put it back through PenDoc again, so that you produce the actual document itself. Okay. Alternatively, if you actually know Haskell, which I don't, okay, I took this example off the PenDoc website, then you can actually write Haskell to go through the thing. Okay, so this part here is actually for this portion here. So you will see that, okay, maybe I'll just show you a small demonstration. The bunches of codes that you saw was here, right? So the black and white one, you remember? The one that was a guessing game, another one which was here, and the third one which was the actual picture here. So these are, okay, the include is not part of PenDoc. It has to, you have to use this, this same script that you saw just now to filter it. So what this does is that instead of reading the content from this portion here, it will read the content from this file. So this file is actually this file down here. So let's say I decided I made a mistake, and instead of ran in, this should be, let's say I want this to be, I don't want this method, I want this to say import random instead, so that we can say this is random.randin. So if that's the case, I can cause cons to rebuild everything. It would discover that I made a change. You will highlight the codes again. You would resize the sample, and you will produce the two slides, which is the HTML version, the first one, and the second one is the PDF version. It does take a while because, yeah, my computer is a bit slow, so you have to wait for it. Yeah, so that should be done. And if I go back, let's say I refresh this one, and we go back to the contents again. Where did I go? Okay. Did I refresh this correctly? Yeah, sometimes. Let me see if I made a mistake here. No. Should have changed. Let me just check. Okay, sorry, maybe not, because I think I made a mistake with the includes. Because I took this off the website, so I think this part here might not have worked as well. Okay, sorry. Maybe I'll just try another change. So, okay, let me do another change from this one instead. Plant UML is actually the one that takes these text documents and produce them as the UML images that you saw. So the images that you saw at this point, sorry, where was the images? Like this one, for example, is actually done inside here. Sorry, where was it? Yes, this one. So if, like, say for example, I forgot to say package upload items, package affected documents, so I just have to add this at this point, and okay, I forgot to mention that plant is actually not a Python tool. It's actually a Java jar. So the only way I can interface with it is through the command line where I pipe the results in. So I took the file itself, pipe it in through the file, and Plant will produce a PNG file, which will again be resized and recreated. Okay, so that should work. Okay, let me see if I can do that. Yeah, so you can see now, instead of directly uploading, I now have another step where I package the affected documents. If this file was included in another document, that same document will have changed as well. Like for example, just to show you in the PDF here, I have to refresh this PDF. Then this one will be would have the extra step here as well. Okay, so let me go back to this one. Yeah, so because sorry about the includes, because the includes part uses the Haskell, I think it may not detect the change correctly, so it didn't do the includes right. I only took this off the PenDoc website. I seriously don't really know how to write Haskell. Okay, some discussions. Because this is a programming module, it is very useful if this could have been unit tested. Unfortunately, Sconce has the problem where you can compile Java files, you can compile C files, which is the main purpose of Sconce, but I can't seem to find it to a way to integrate unit testing in. So unlike other tools like Maven or Ruby where there are ties to unit testings, here I just can't seem to be able to do it. So that was an issue. Okay, because it'd be nice if I could check my codes run correctly before I actually showed it, which was a good thing. Another thing is it's a slightly high learning curve. So maybe within our school of Infocom, it is still possible for our lecturers to understand this context and try to recreate this for their own modules. But outside of our school, I think very few of our lecturers will be able to do this as compared to their knowledge with Microsoft Office. On that same note, it's also difficult to customize. To customize this, you actually have to know what to write, either here at the construction page, which actually builds the various items and resamples them or makes them smaller or produces the PDF. Or you have to customize and write scripts, which is this one, which do things like resample, which is not built into Sconce itself. Unfortunately, even within SOI itself, very few modules do this. Okay, mostly the modules that I've been involved in rather than other modules. Yeah, and with that, I think that's all. Any questions? Yes, so sorry. Yes. Yes. Okay, it's so I don't have a prepared example and I can't show you yet because I can't show the actual file because the exam isn't done yet, but I can show you what I did. If I can find it, should be. What did I do? Oh, sorry. Okay, so what happened is that I ran. Okay, if you didn't see this one, what I did was I took the UT and which is the understanding test, the exam itself, and I run it through this method called clean. Okay, so clean is actually so clean will run PenDoc itself, which asks it to produce JSON. Okay, so I will then read in the JSON using Python. Then I will go through the each item if it's not the answer, and I'll strip it out. Okay, so what is its answer? Its answer is just, where did I put it? Oh, it's just here. I specially mark the answers. So for example, answers are always marked with header 2. So anything in the header 2 is an answer, or anything in the code block that has the word answer inside is an answer. So like for example, if I wrote those codes that you saw just now, in this case, wait, let me just show you the previous one. So like this one, if I put the word answer here, right, that means that I tagged it as an answer. So you'll know that this is an answer for the question. So what happens is that if it's an answer, I will strip it out. So I only assemble those parts that are not an answer. Yeah. Okay, I hope that answered the question. Yeah. Okay. Any other questions? To be honest, this would have, if you know Haskell, this might be better to be done in Haskell, because this doesn't handle if, for example, my code block is hidden inside another code block or something like this. Some odd cases which happen. All right, but if you structure, because I wrote the exam file, so I know I won't purposely write like that. So that's why this method is good enough as it is. Okay. Any other questions?
Last question, anybody? Not, thanks to Simon.
All right.
Thank you for your talk.
Thank you.